So I did put the quiz grades on Blackboard this morning, so they are there now. I don't see an obvious place to put it on your graded quiz on Blackboard. So I'll look to see if I can, but if you do want to see what you got off, you can send me an email and I'll send you back the graded quiz. And as always, the answers are on Blackboard. Also typical after quiz, so 3 points wasn't on the quiz, 3.5, sorry, volume, wasn't on the quiz, but I'm going to wait to see if you have questions on that because I want to start the next thing, which is 3.7. And really 3.7 and 3.8 go together. One is mass and one is center mass, and they really go together. So we'll do both those today. So I'll quickly go through 3.7, get into 3.8, and then we'll do more examples tomorrow. So 3.7 is mass. And start, there's the easy example. If the density is constant, how do you get the mass of something? Oh, so yeah, so what I said was for 3.5, kind of typical after quiz, I'll wait until tomorrow to look at 3.5. So today we'll do 3.7, 3.8. Tomorrow we'll pretty much do nothing new, just go over homework problems in 3.5, 3.7, and 3.8. So just to keep going. Okay. All right, so if density is a constant, how do I get the mass of something? It's just density times volume. If density isn't a constant, then as you might expect, we're going to have to do an integral. And the problem is, you can kind of guess this. From Calc 1, you were able to get the area of something using one integral. How many integrals do you think you have to do to get a volume? In some ways, it's going to depend. It'll either be 2 or 3, so it's either going to be a double or triple integral. And that will depend on the density. Because if the density is in 3 dimensions, then of course, that could have 3 variables, in which case we'll need a triple integral. So it actually sort of depends. But we'll certainly need at least 2. So in some sense, we're looking ahead here. So we're only going to be able to do special cases. And in particular, we're going to have 2. The text does 3, one of which we'll skip, although I think 1's still in the homework. Okay. So let's look at 1. Start off with the easy one, something that is essentially one-dimensional. So we have a wire, and in this text, he's defining the density here as a length density, which I'll talk about in a second. And let's suppose it's given by x squared plus 1. This is a delta for density. Is x squared plus 1 pound per cubic foot. because I give it in pounds, I'm putting the mass in quotes because is pounds a mass? The answer is no. Pounds is a weight or a force. So officially, I should be doing the English units for mass, which I'll write in the next slide, is a slug. So I'll remind you what the different units we could have here. For now, we're not going to worry about it. So we have a wire. And if you think about it, it doesn't make sense to have mass for a one-dimensional object. So what we're doing is we are pretending that the cross-section at a cut has an area of 1. Therefore, the volume is really just the length, because it's length times the cross-sectional area, which is 1. So as I said, we knew these special cases. And since the density only depends on the x value, it doesn't matter how far we are the x-axis. So in some ways it's three-dimensional, but we're thinking of it as one-dimensional. And from here, you can kind of figure out exactly what we're going to do. Typical integral thing. We're going to slice it into lots of little pieces. And let's suppose the width is delta x. On the little pieces, the density is basically constant. So we can use what we had before, which is mass is just volume times the density. And I'll put the 1 here to make it a volume, but you don't obviously need the 1. So delta x is the density at that point. Really, we decide if we want to use the left endpoint or the right endpoint or the middle, but we're going to let delta x go to 0, so it's not going to matter. So we're going to multiply the density times, that is the volume. And then let delta x go to 0. And get the mass is equal to yes, okay. So as usual, you'll tell me if it goes out, and I have the microphone and I'll unplug it. Sometimes it works. And this is true from, okay, I'm not sure what I just did there. From 0 to 2. And we get sort of the mass. As I said, this is really a weight. So this is the really simple example. And as I said, we're kind of pretending because really we need either a double or a triple integral to do this, depending on how many variables the density has. Okay. So for wires, it's just really easy. The mass is the integral of the density because the dx is essentially the volume because the cross-sectional area is 1. So 1 times dx is the cross-sectional area times the length, which is the volume. So here's the basic one. Any questions on this? And 14, let's see. Oh, yes, 14 thirds. Because 8 thirds plus 2. Thank you. As always, you're double checking my arithmetic. So any questions on this? Here's the basic idea. For this section, I'm not going to worry about, so the volume isn't 1. So if I look at this, oops, wrong place. This is the volume. The cross-sectional area is 1. We made it that to make it simple. So obviously this doesn't have to be true. The cross-sectional area doesn't have to be 1, but we make it 1. In some ways, we can make it other numbers. It just means that we'd have a constant that we could pull out of the integral. So we might as well make it 1. And then when I multiply the cross-section times the length, that's when I get the volume. So this is now the volume, the 1 times the dx. Sorry about the messy writing. So any other questions on this? Okay. So let me aside because as I said here, we're doing pounds. So let me just do a quick slide into units. I don't worry about it too much, but you should be able to do this. So in units for the United States, we have pounds. Which is a weight or a force. And that depends on gravity. So your weight will change depending on what the gravity is. And as I usually ask this just because who has heard of it, but I already told you. We pretty much never use it, but mass in US units is a slug. Also came from England, but it's okay. And because, actually, let me ask, what is force in terms of mass? So force is equal to m times a. In English units, what is gravity? Anyone remember? You should be using meters and so on, but so what is the number for gravity in English units? Therefore, one slug at regular gravity is 32 pounds. Officially, yes, gravity is feet per second squared. So there is something there, but so as I said, this is probably the only in physics and maybe here about the only place you'll ever hear slug. And in the way of things, so in the US we tend to use pounds, which is a weight or a force. metric, you tend to use kilograms. What is kilograms? Is that a mass or a force? So this is a mass. And again, you probably don't hear this outside. What is the force in metric? In some ways, there are two ways of doing it. One is just, this is what it is. It's kilograms per times meters per second squared. So kilogram mass times acceleration, like the last one. But this is a Newton. And while I'm here, I might as well put in, what is gravity in metric? What's the number? Nine 9.81, depending how far you want to go. 9.8 is fine for us. Okay, so this is kind of just in the background. As I said, I don't worry about it too much, but we really should be able to be doing it. Okay, so next example. So give you a minute to look at this. Okay. So second example. So now let's look at a two-dimensional thing. So here's our plate. And again, we have to cheat a bit because that's two-dimensional. We can't talk about mass for a two-dimensional object. So we'll assume it's a plate of 1 unit thickness. So in this case, 1 meter. That way, area is basically volume. And since our density only depends on x, we're going to be able to do this. So if density depended on 2 variables, which it certainly could because it could change as we change x, we could actually, we would actually need doubles. And in some ways you can see, again, what we would probably do. We do the usual integral thing, break it up into slices. On each slice, the density is basically a constant. And so we would get mass on the little slice. If again I make these delta x, is about equal to the density at that point. Again, officially we might do left or right or middle, but it doesn't matter because we're going to let that go to 0. And multiply by the area. And in some ways, this goes back to Calc 1. So I want to get the area of this curve. Well, since we're assuming the thickness is delta x, we assume it is basically a rectangle. So this is the area is basically height times the thickness. The width, sorry. And then thickness is 1, which makes it a volume. So let me do kind of an aside. And in the next section, we'll add one more level. So I'll go back to the Calc 1 question. How would I get the area of this thing? So I'll write the integral because that's hard to write. So it's the integral from, in this case, 0 to 2. And in general, how do I get the area of a region? It's the top curve, the bottom curve. So therefore, in this case, this is y equals x squared. Yep. And then the mass will be equal to, so according to this thing, the density times the area. And so you can see basically what we're doing is we're taking the area integral down and we're adding in the density. And again, we're getting the same thing. This is the density. And this is sort of the volume, because we're assuming the thickness is 1, the x squared is the height, the dx is the width, and we have 1 for the thickness, so that becomes a volume. And here I'm going to start my usual laziness. We can go through. At the end, we would get a number, which I think I did. So I got 28 over thirds, but as is often the case, I would probably just have you set it up. Okay. So this is kind of the next level, and you'll see, especially in the next section, that really this new thing, this two-dimensional one, the plates, what we're going to get is integrals that kind of get more complicated as we go. So we have the basic area, then the mass, and then we'll do center of mass. Okay. There's a third one that the text does, which is if we do a solid of revolution, we can actually do the actual volume. So instead of these where it's sort of a volume, if the density just depends on the radius, r. I think of that sort of as another made up example, so I don't do those. I think there's one in the homework problems, but you can ignore it. So all of our evolutions you can ignore. So really we just have for this section that these two, wires and plates. So any questions on this? So now what I'm going to do is quickly go into 3.8, because since 3.8 is built on top of 3.7, we'll be doing 3.7 problems as we do 3.8. So we're doing more examples in any case. So let me move into 3.8, which is center of mass. And again, we're going to have to cheat there. As I said, I'm doing what I often do, which is go through stuff quickly, and then we'll do a bunch of examples tomorrow. And for this one, let's do kind of a round thing. Just make sure you're okay with the mean. Center mass is just going to be a mean. So here I have some numbers. So get the idea of how we would do this using something that you should already know. So what is the mean of these this case, how many are there? 22 numbers. So first, let me do it in the usual way. Usual way is I start in the wrong order, so we add them all up. We divide by how many there are. In some ways, the number here doesn't matter because this is just to get the idea. But let me just check. So 60, yeah. Okay. But let me rewrite this kind of in a different way. Let me spread it out. So I can write about each piece. So here we have the different values, 1, 2, and 5. This I can kind of think of as a density. And if you go into probability, this will become more explicit. And then you can think of as the total mass. So the 1 times 5 here is equivalent to saying, well, I have these numbers 1 of density 5, or weight 5, if you want weight better. And so the weight of those numbers is 5. And same thing with 2, same thing with 5. So this is kind of the background, which is center of mass is coming from average. So let me go back to an example. So we have a wire with a given density. So might as well do in the background since we're going to need this. As I said, in doing the center of mass, we do 3.7 questions, which is why it worked. So this is the easy one. So if we have a one-dimensional object, we're assuming the cross-section is 1. Then the mass is just the integral over the region of the density. And here, since I'm going to use it in the second part, I'm actually going to get a number. And I didn't get a unit, so I can't tell you if that's pounds or kilograms, but whatever. Okay. So what we might do again is to think about it, we would break it into lots of little pieces. We would get the weighted average. So here we have a bunch of points. Let's pretend it's just these points. The center doesn't really matter. And I would multiply that times its weight. So I would do the x value, whatever it is, times the weight, which is the density times the volume. And here I'm just going to skip straight to saying, okay, so what I'm going to do is multiply x not sure why I switched the order there. multiply the x value times the density, and divide by the total mass. So this is essentially doing what I did in the discrete example in the last one, which is I multiply all of them, except here they're an infinite number, so I need an integral. Multiply them by their weight, and add them up, and then divide by how many there are, which in this case is a weight, so total weight to total mass. So divided by 7.5, so I'll bring the 2 7s. And before I get something like that, as always, you're double checking me. Now this would be the center of mass, which is the balancing point. So if I had this wire, if I put my finger at 11/21, it would balance. So as you might expect, given this, which is the density increasing as x increases, it's a little bit to the right of the middle, because things further up are heavier, so the center is a little bit past the halfway point. So that is our center of mass. Yes, sorry about my rhetoric. Yes, 3/2 x squared. So any questions on this? Right, so let me go to the two-dimensional one. So again, this is easy, which is to get mass, you integrate the density. To get center mass, you multiply density times x. So any other questions on this before I go to the plate? Okay. There's my plate. Again, I assume it has a unit thickness, so I can pretend it is volume. But as I did on the mass one, let me do a previous problem, which really has nothing to do with this section, just see how things build on top of each other. So first, let's ignore the density and just ask what's the volume of this thing, or area. So I'll talk about why we use x in this one. That way I can bring it in. So go back to Calc 1. What would be the area of this thing? It's the integral of what? Not sure why I have parentheses, but why not? So it's all the top curve minus the bottom curve. In theory, if they cross, we'd have to split it up, but we're not going to do anything that complicated with this math stuff. So that's the Calc 1 question. So from the previous one, what will be called mass, because that 2x minus x squared will become a volume. So what am I going to put in the integral for the mass? I'm going to multiply the volume, the 2x minus x squared, by 1. And again, 0 to 2. That's a 2. And this one, because I'm going to use, let me actually get a number. Look at that. That's the mass of that plate. And now we do kind of the typical physics thing. We want to find the center of mass, which is going to be a point, but we can break that into the two pieces by themselves. So what is the x coordinate? What is the y coordinate? So we want to get the average of the values of x, average of the values of y. And so here's the new part. This is what we're going to get. And the idea is we want to find the average value, in essence, of the x's given the weights. So we multiply the values, the x all the way from 0 to 2. And then this and this is the weighted average, is the weight. So you can see how they build on top of themselves. So the area is just the F minus G. The mass is the density times F minus G. And then the x coordinate of the center mass is x times density times F minus G, all divided by the total mass. So in this case, the total mass is 20 over 3. So that would become 3 over 20. And again, I'll skip the things because as with most of the time, I just have you set that up. So let me stop here for a second and ask you if you have any questions on this new part. Yeah, so we will also find the y value in a second. But any questions on the x? So let's ask theoretically at least. So this is the average value of the x. How do you think we would get the average value of the y's? Pretty much the same integral, except what would we change? Pretty much this. Just to get the average value of the x's, we multiply the x times the weights. To get the average value of the y's, we would want to multiply by y. So really, for the next part, we would want to put a y there, but we can't because that makes it have two variables, which means we would need a double integral, and we can't do that for now. So let me erase this. I'll draw the picture again because we'll need it. So D. here's our slice. So we want to look at a typical slice, and we want to find the center of mass in the y direction. And as I said, what we really want to do is do the y value times its weight, but we can't. Here, though, we've made it so it's nice because the density only depends on x, which means that the density is going to be constant on that line segment. And therefore, where's the center going to be? It's just going to be the middle. Because it's constant. So I check. I'm just doing it this way so I have more room. So if I have a line segment in one dimension from A to B, what is the center? So how do I get that middle number? Okay. So this is what I would like to do to get the y coordinate for the center mass. But I can't because I can't use y. But I know it's the center. So here I did it from A to B. We're going from F to G. How do I get the center of F at X and G at X? And let me remind you that here we're using this is F. This is G. Pretty much the same thing. It's going to be the F plus the G. So the Y will become that. Because 2x is the value at the top at that value of x, at a generic value of x. X squared is the value at the bottom of the line segment, and divide by 2 to get the middle. And then the rest is the same. And again, which you wouldn't have to do. Going through the integral, I get 2. And therefore, the center of mass is this. Little thing, this often is a theoretical one. If I had something that had holes and so on, it could be that the center of mass isn't actually part of the solid, but we pretend it is. Also, we're pretending this is 2 dimensions. In theory, since we're assuming that it has unit thickness 1 and density doesn't depend on it, the center of mass really is halfway up that unit thickness. So let's try one more of these. Any questions on this? So, one more. again, just so you see how it is building on top of each other, even though this has nothing to do with the section, let me do the integral for the area. Oh, this is going to be a, we'll see. Could be a bad example. So here, what would be the integral for the area? Yes, so you could just see the triangle formula, but let's set it out. So it'd be the integral from 0 to 5, top curve, Hello, anyone still there? Okay. My full internet went out, so I'm now on my phone. So I think I'm going to stop because I'm not going to be able to write very well on my phone for this thing. So uh, for tomorrow, go to the discussion board, tell me when you have other tests, and start working in homework for 3.5 if you haven't already, and then these two sections, 3.7 and 3.8. And as I said, what we'll do tomorrow is pretty much just do more examples. So before I go, any quick questions? Okay. So as I said, since I only have connection through my phone, which doesn't have a very good connection, I'm going to stop now and I will see you tomorrow. So let me see if I can figure out how to stop the recording here.